Welcome back to the Deep Dive. Today, we're tackling a genuinely fascinating puzzle.
We really are.
It's one that pits, Cold War engineering against 21st century digital warfare. We're unpacking sources that focus on what is arguably one of the most iconic aircraft ever, the U-2 Dragon Lady.
It's a compelling topic because it forces us to confront this paradox.
Yeah.
You have a platform designed in the 1950s that, according to these sources, isn't just flying, it's being modernized to be a linchpin for the military's most advanced digital strategy.
Exactly. Our mission today is to, it's not just to celebrate its legacy, but to really understand its current status, its future role.
Right.
We're focusing on how this high-altitude platform stays so relevant in the age of, advanced digital warfare, and we're drawing heavily from insights provided by Lockheed Martin's Skunk Works.
And that strategic pivot is absolutely the core of this whole discussion. The U-2 Dragon Lady isn't some standby asset.
Yeah.
The source material is very clear. It's flying 247, 365. It's ensuring global security with this incredible high-altitude performance.
So we're looking at technological flexibility, data-centric upgrades, all positioning this old airframe for something new, for enabling joint all-domain operations, JDO.
It's the ultimate example of old airframe, new brain.
It is.
And we really need to look at the unique characteristics that even made this possible.
Okay, let's start right there, with the foundation. For anyone who might be curious, what is the U-2? It's characterized as an agile and reliable high-altitude ISR aircraft. Intelligence, surveillance, and reconnaissance.
It flies so high it's practically in space.
Right.
And that idea of agility and reliability is, it's steeped in the Skunk Works culture. The U-2 is just synonymous with Lockheed Martin's Skunk Works, the group that was built to solve what looked like impossible engineering problems.
And solve them quickly.
Yeah.
The famous Skunk Works ethos. It's a culture we hear about a lot, but these sources give us a pretty clear principle they operate under.
They do. Their whole philosophy, and it's highlighted right in the material, is that their team just assumes it can be done.
I love that.
Every challenge is solvable. So they partner with customers, in this case the U.S. Air Force, to anticipate what's coming next. The capability gaps, the tech needs. It's an acceleration mindset.
And when you marry that innovation philosophy with the U-2's own core mission, that it's always active, always flying, you realize this platform has an operational commitment that very few others can match.
It demands incredible readiness. Think about it. This is an aircraft that needs a chase car just to land safely.
Because the pilots can barely see out of those suits.
Exactly. Bulky pressure suits, super low landing speed. That level of commitment requires unique training, unique readiness, unique dedication to just keeping that airframe in the sky.
Which is probably why we keep seeing news confirming it's still so vital. The source snippets show its ongoing life, like that story from December 8, 2025, about U-2 1099 returning to flight.
Fully restored and reborn.
Yeah, fully restored and reborn. And earlier that year, Sam Ekholm gave the public that rare look at actually flying the U-2. It's active, it's evolving.
It reminds you this isn't some theoretical platform. It's a living, flying piece of operational hardware.
Okay, let's unpack the core tech puzzle here.
Yeah.
If the platform is decades old, what allows it to compete with, and in some ways even surpass, much newer fifth-gen aircraft?
The answer, according to the sources, is in two key areas. Its physical capacity and its embrace of digital open architecture.
Modularity.
That modularity is truly the secret sauce of its longevity. The source highlights the U-2's technological flexibility, which allows it to demonstrate and prove entirely new tech in
weeks.
In weeks, not years. That speed, that ability to rapidly field new sensors or software, that's the core appeal.
So the U-2 acts like the ultimate test bed. But why can it handle that? Why can it accommodate this rapid change when, smaller, maybe stealthier platforms just can't?
The physical reason is the first key nugget.
Yeah.
It's got superior size, weight, power, and cooling.
Swapsy.
Think of it this way. A fifth-gen fighter is built for speed and stealth. It is packed tight, it generates immense heat, and every cubic inch of space is precious.
So trying to add a new server rack is a major challenge.
A major structural and thermal challenge, yeah. But the U-2 is different. It's essentially a massive flying tube with huge wings designed to carry enormous payloads to the edge of space.
Right. Its original mission was all about payload and altitude, not so much stealth.
Exactly. And that creates the physical infrastructure, that superior swap-C, that makes it the optimum platform for integrating new, complex payloads. We're talking about processing power equivalent to a small server farm.
At 70,000 feet.
That's 70,000 feet, which it can actually cool. That capacity translates directly into a combat advantage because you can install sophisticated sensors and the powerful processors you need to run them
Okay.
at the same time.
So the physical structure gives it the space, the capacity. But now let's talk about what they're doing with that space. The sources say the mission is shifting. It's not just about intel gathering anymore. It's about being a digital node.
That's where the crucial technical upgrade comes in. Its modern avionics suite is Open Mission Systems compliant, OMS compliant.
Okay, we hear plug and play a lot, but let's go a bit deeper. What does OMS compliant actually mean for, say, a systems engineer?
It solves the biggest roadblock in defense contracting, the software bottleneck. Historically, military systems used proprietary, tightly coupled hardware and software. If you wanted to upgrade a radio, you'd have to rewrite millions of lines of custom code.
That sounds slow and expensive.
Slow, expensive, and rigid. It's like trying to change the engine of a Formula One car. Everything is custom fitted.
Okay.
But OMS standardizes the communication protocols, the data formats, the digital interfaces across the whole platform. By being OMS compliant, new systems can be integrated quickly and affordably.
It's a true plug-and-play capability.
It is. The systems are all talking the same digital language. You can add new sensors, new processing modules, without overhauling the core flight software every single time. It just massively reduces time and cost.
And this modularity, it isn't just a theory. It's driving a major real-world modernization effort right now.
It is. This is the Avionics Tech Refresh Program, the ATR program.
And the goal of ATR.
The goal is to expedite battle space capabilities, but the massive, almost revolutionary milestone is that the ATR makes the U-2 the first fully OMS-compliant fleet in the entire Air Force.
That's incredible. The U-2, this decades-old platform, beat all the newer assets to full OMS compliance.
It tells you everything you need to know about the adaptability of that airframe.
And we have a hard date for this, September 26, 2023. That's when Lockheed Martin Skunk Works and the Air Force completed the first flight of the ATR program.
It proves that the whole philosophy works. You leverage an adaptable physical platform to rapidly incorporate bleeding-edge digital standards.
So let's focus on the strategic consequence of this. The discussion now shifts entirely to data processing. The sources are explicit. The future fight is all about data.
This is what they call the quantum leap U-2. Its value has shifted from just being an observer to being an indispensable node in the digital battle space. It's positioned to collect, process, and share data.
Fulfilling that JADO vision.
Fulfilling the JADO vision, where information flows seamlessly across every domain, air, land, sea, space, cyber, all of it.
So it's really about data velocity. How fast can raw input turn into a decision someone can act on?
That's the key metric. And the U-2 gets that speed through a streamlined three-step process that's focused on removing human bottlenecks.
Okay, what are the steps?
First, it collects data at altitude. Second, and this is critical, it processes that data using powerful onboard computers, using machine-to-machine processing.
And what does that machine-to-machine processing actually let it do?
It lets the U-2 automatically analyze raw sensor inputs. I mean, say, identifying a target or tracking a signature without needing to send massive amounts of raw data back to an analyst on the ground.
It processes the data on the edge.
Exactly. It dramatically reduces that data-to-decision timeline. The information that gets passed down is already fused, prioritized, analyzed. It's ready for immediate action.
That kind of speed is essential. It's the difference between just watching an event happen and being able to respond to it almost instantly.
Absolutely. So the third step is sharing that processed data. And that's where its open architecture really shines.
And that sharing part is so critical because it has to talk across generations of tech. It's no good if it can only talk to brand new jets.
Right. The source emphasizes that the U-2 shares this vital, processed information across networks that include both legacy and fifth-generation platforms. It acts as a high-altitude translation bridge, a communication hub.
And this communication, it's not just limited geographically or structurally, it talks to everyone.
Correct. The U-2 is designed to communicate securely and simultaneously, at all tactical, operational, and strategic levels across multiple domains. It makes sure that the intelligence it gathers at 70,000 feet is immediately available.
To a soldier on the ground, a ship at sea.
A fighter jet engaging a target. It's a central, resilient hub.
So if we connect this to the bigger picture, it really seems like the ultimate value of the modernized U-2 is less about where it flies and much, much more about what it does with the information it gathers once it's up there.
That's the perfect summary.
It's gone from being a flying camera to being a high-capacity server that translates data for the rest of the system.
That's it. Its altitude gives it survivability in that incredible field of view. But its massive swap C and its OMS compliance give it the ability to process and share data at the speed you need for a modern distributed fight.
So it proves that software and open architecture are now the primary drivers of military capability.
It does, even eclipsing the importance of the physical airframe design itself.
Which brings us to our conclusion. For you, the listener, the key takeaway here is that the U-2 Dragon Lady represents this successful fusion.
Yeah.
A proven, high-altitude airframe, which offers that indispensable capacity with bleeding-edge digital open architecture, specifically through OMS and the ATR program.
And its continued relevance is entirely because of its profound adaptability. Because of that modular design and the Swap C, it's still a highly cost-effective and agile choice for rapidly fielding next-gen capabilities.
It's an operational laboratory.
It is. It's proving out future networking standards today.
This raises a really important question then. If a platform designed decades ago can be upgraded in weeks to become the first fully OMS-compliant fleet in the Air Force, what does this aggressive emphasis on open architecture and plug-and-play flexibility mean for the life cycle of all future military tech?
Well, think about it. Are we fundamentally moving away from these massive, multi-decade, highly specialized programs that rely on proprietary code?
It seems like it.
Is the future of defense acquisitions centered instead on designing simpler, agile platforms that are just adaptable nodes? Prioritizing the software pipeline over the bespoke nature of the hardware.
A complete philosophical shift.
That shift, demonstrated by the Dragon Lady, it suggests a much faster, more agile, and hopefully a more affordable path for defense modernization going forward.
Always leaving us with something to chew on. Thank you for sharing these sources with us and letting us take this deep dive. We'll catch you next time.